To create a machine learning project, you would traditionally use a framework like TensorFlow or scikit-learn on top of a high-level language like Python. There's a lot of benefit to still learning some of these frameworks, but we're going to use a tool called Edge Impulse as it just makes model training much easier. It also gives you a graphical representation of what's going on, so it helps with understanding the process as well. Edge Impulse was founded by Zach Shelby and Yan-Jong Boom in 2019. The idea was to create an online tool that would help make machine learning easier for embedded engineers. Rather than needing to learn one of the programming frameworks for machine learning, we can use this tool to do all of the heavy lifting for us and get back to focusing on the problem we need to solve. Create a new account and log in. From here, you'll want to create a new project and give it a memorable name. Once that's done, click OK, and click on your project to open it. The left pane will show you the steps needed to collect data, create a machine learning pipeline called an impulse, train the model, and deploy it to your embedded device. When you first log into your project, you'll be at the dashboard. This will show you the next steps you need to complete your project. At the top, you'll see some tabs. If you click on Keys, you'll find your API key, which is used to connect to your device, like a smartphone or microcontroller, to collect data or do live testing. There's also the HMAC key, which is used to connect to the ingestion service. This ingestion service is a way to programmatically send data to Edge Impulse. It's great for scripting or automating the data collection and training process. We won't get into this in this course, but know that it is available so you don't have to do data collection by hand. There are a few ways to send data to the Edge Impulse service. The most straightforward method is to upload files directly. Right now, Edge Impulse accepts audio files, image files, and raw data stored in CBOR or JSON format. There is a command line tool that will let you create a script to automatically upload these files as well. If you have one of the supported development boards, like our Arduino Nano, you can run a special firmware on that board and a command line tool on your computer to send sensor data to Edge Impulse. A smartphone will also work, and it's a great way to try out some of the demos if you don't have the Arduino. Finally, Edge Impulse supports direct connections to other cloud services with their enterprise account. In the future, I'm sure we'll see some boards that can automatically upload data using their built-in Wi-Fi connection. For this course, we will focus on the microcontroller board to computer and smartphone methods. If you are using your smartphone for the demo, go to Devices and click Connect a New Device. Click Show QR Code. Use whatever QR code reader app you have on your phone to read the code, which will take you to a specific web page. You should get a notification that your phone has been connected. Click Get Started and you should see your phone listed as one of the possible client devices. If you are using the Arduino Nano, start by plugging it into your computer. Press the Reset button twice in quick succession to put the board into bootloader mode. You'll know it worked when the yellow LED starts to pulse. Back in Edge Impulse, go to Devices and click on Connect a New Device. Click on Browse for Dev Boards and click the link to view the instructions for connecting the Arduino Nano 33BLE Sense. The first thing we need to do is install Node.js. So head to nodejs.org and download the installer for your operating system. Run it, accepting all the defaults. Once that's done, you'll need to install the Arduino Command Line Interface tool. Head to the Arduino CLI page. For Mac OS, you can use this homebrew formula. For Linux, you can download the install script with the curl tool as shown here. For Windows, download the zip file for your OS version, which is 64-bit for me. The easiest way to do this is to extract the .zip file directly into the C drive. For me, the executable is in C Arduino-CLI. In the Windows search bar, search for Path and click on Edit the System Environment Variables. In that window, click on Environment Variables. Click on Path under your username and click Edit. Click New, click Browse, select the Arduino CLI folder and click OK. Now you can use the Arduino CLI tool from the command prompt. Open a command prompt and enter npm install-g edge-impulse-cli to use the Node Package Manager to install the Edge Impulse command line tool. Back on the Edge Impulse Nano page, find the link for the latest Edge Impulse firmware and click it to download the firmware package. Unzip it and run the script associated with your operating system. For me, it's the batch file. If asked, tell your operating system that you want to run the script. As long as your Arduino is in bootloader mode, the script should find the board and begin to upload the firmware. Wait until it's done and press any key to close the window. After, press the reset button once to reset the Arduino Nano board. Open a command prompt and enter edge-impulse-daemon. You'll then be asked to log into your Edge Impulse account with your username and password. You should be asked to select the serial port associated with your Arduino board. If you're on Windows, this might require opening the device manager to figure out which COM port goes to the Arduino. Select the serial port and press Enter. From there, you'll be asked to select a project. Select the motion detection project we created earlier and press Enter. You can give your board a name for the project devices list, but I'll leave it as this MAC address for now. Press Enter, and the tool should connect your board to the Edge Impulse service. Head back to the Devices page in your Edge Impulse project, and you should see the Arduino board listed alongside your phone. In the next lecture, we'll use these devices to collect data for our machine learning project.